Welcome to Module 7, Introduction to Neural Networks. This video provides you an overview of neural networks. Neural networks are a subset of machine learning that is inspired by the functionality of the human brain. These networks are based on a collection of connected units called neurons, which collectively process information by responding to external inputs. This module will cover the basic structure of neural networks, introduce the concept of activation functions and backpropagation, and guide you through a simple implementation of a neural network. Finally, we will touch on the fundamentals of deep learning, setting the stage for more advanced studies. What is a neural network? A neural network consists of layers of interconnected nodes or neurons, each linked by weights and biases which are adjusted during the learning process. Typically, a neural network has three types of layers. Input layer receives various forms of input data. Hidden layers perform computations through neurons that process inputs from the previous layers. Output layer produces the final output of the network. Each neuron in these layers applies a simple mathematical function to the input data, which collectively results in the ability to perform complex transformations and predictions. Key components includes 1. Neurons, basic computational unit of the brain. 2. Weights, influence the input of the neurons. They represent the strength of the connection between units. 3. Biases, additional parameters which help models in a way that they can fit best for the given data. 4. Activation functions, determines whether a neuron should be activated or not, helping the network to learn complex patterns. Activation functions play a critical role in neural networks by deciding whether a neuron should be activated or not, based on whether each neuron's input is relevant for the model's prediction. They introduce non-linear properties to the network, which allows them to learn more complex data like images and audio files. Types of activation functions include Sigmoid, a function that maps the input or x values between 0 and 1. ReLU, or rectified linear unit, allows only positive values to pass through it. Tanh, or hyperbolic tangent, maps input values between -1 and 1. Backpropagation is the backbone of neural network learning. It is a method used for training the network, involving a forward pass to calculate the output and a backward pass to update the weights and biases in accordance with the error. Alright, so let's dive into the steps involved in backpropagation. First up, we have the forward pass where we calculate the predicted output. Next, we move on to loss calculation. This is where we determine the error in the predictions, basically the difference between the predicted and actual values. Finally, we have the backward pass. Here we propagate the error back through the network to update the weights and biases, aiming to reduce the error. Introduction to deep learning. Deep learning is an advanced type of neural network with multiple hidden layers, each improving the network's ability to learn from vast amounts of unstructured data. It powers many modern AI applications, including self-driving cars, voice-controlled assistants, and more. Image recognition. Image recognition tasks can be efficiently tackled with deep learning. Convolutional neural networks, or CNNs, a class of deep neural networks, are especially effective for processing pixel data. This module has introduced you to the fundamentals of neural networks, from basic concepts to more advanced applications in deep learning. With these foundational knowledge, you're equipped to progress to more complex topics and utilize neural networks for various practical applications. Continue practicing with different data sets and experiment with changing the architecture of your neural networks to see how it impacts performance. As you move forward, keep experimenting and learning. The field of neural networks is vast and constantly evolving, and there's always something new to discover. Thank you so much for taking the time to watch this online training module. I hope you found it valuable and insightful. To stay updated on upcoming content, including new modules, case studies, and quizzes, be sure to subscribe to my channel and share in your community. Your support helps me create more content that enhances your learning experience. Don't miss out on the next steps to watch other module videos to deepen your understanding and apply the concepts in real-world scenarios. Thanks again, and I look forward to seeing you in the next video.